Okay, so we continue our class with vector in space. Okay, so basically vector in space, as you can see, when we say space, mean it is in three-dimensional space. Okay, so you will have three coordinate for the vector. So if let's say we have vector v and w, and the coordinate for vector v is v1, v2, v3, and w is equal to w1, w2, and w3. So you will learn about the properties of vectors in space. So for the first property, if let's say we say that v is equal to w, it is only if and only if for every coordinate, as you can see here, is equal to each other. v1 equal to w1, v2 equal to w2, and v3 equal to w3. And the magnitude, again, if you still remember, magnitude means its length. Okay, so the magnitude of vector v can be calculated in this by using this formula. Okay, so we put the modulus because we want to make sure that the value is always positive, and this is the formula. Just square every point in the vector v and plus it together, and then square root the summation. Okay, so that is the magnitude of vector v, and we can also calculate what the unit vector by using this equation here. So basically this is the vector v divide with the magnitude. Okay, so you will get, by using this formula, you will get the unit vector. And if let's say you need to add two vectors together, so means you will add the position, the coordinate of the two vectors together. Okay, so continue with property number 5. So if let's say we multiply a constant which will be some number, and let's say the constant is k. So if you multiply the constant with one vector, so means you will multiply the constant with all the coordinate. Okay, and when we set 0 vector, means you automatically know that it will be 0 0. This is, I think this is not 0, this is original point, equal to 0 0 0. Okay, and v plus w is equal to w plus v. And if let's say u equal to u1, u2, u3, then u plus v in bracket plus w can also be written as u plus in bracket v plus w. This one is same to each other. Okay, and u plus 0 will equal to u, and u plus negative u will equal to 0. Okay, the property is quite similar with common additional properties. Okay, we continue with properties number 11 until 15. So if let's say we have two vector being added together and we want to multiply with other vector, you can also expand like this. So each of this vector will be multiplied to that one vector. Okay, you can also write it in this form. It will give you the same answer. Or if let's say two vector being added together and then you multiply with a constant, you can also write it in this form. Means you expand this bracket here and you get this equation here, so it will give you the same answer. And you can also, if let's say three vector being multiplied together, you can write it in this form also. Means if you separate the bracket, you change the bracket, it will give you the same answer. And a vector being multiplied with 1 will give you that vector, and 0 multiplied to a vector, it will give you 0. And if let's say you put modulus cu, means c is a constant, u is a vector. Okay, you can also take out the constant out, and sorry, this is not constant, this is calculating the magnitude. Okay, so if let's say you want to calculate a magnitude for a vector that has been multiplied with a constant, you can also take out the constant and calculate the magnitude of the vector first, and then only you multiply with the constant, you will get the same answer. So basically this is the 15 properties of vector in space. So basically I think you can uh, remember these properties easily because it is not unusual. It's like a common properties for a number, right? Except this is apply for a vector in space. Okay.